Just weeks ago, astronomers thought they knew exactly what to expect. A faint, icy traveler from the stars would slip quietly past Mars, barely noticed. But then, the impossible happened. In less than 48 hours, this mysterious object erupted, blazing 6 times brighter than any model predicted, and swelling into a green cloud half the size of the sun. Telescopes on Earth watched in shock until suddenly they couldn't. Now, racing at nearly 70 kilometers per second, this alien visitor is slipping out of our view, heading straight into the glare of the sun, and with it vanishing so quickly, the questions are only getting louder. Why is this so-called comet breaking every rule of physics we know? What is hiding inside its strange green glow? And is it really just another piece of frozen rock, or something far stranger? Astronomers had predicted a quiet, almost forgettable passage. 3I Atlas was supposed to drift past Mars like a faint ghost in the sky, little more than a footnote in the history of interstellar visitors. But instead, it defied every expectation. In the span of just 2 nights, its brightness surged 6-fold, an eruption no comet model could explain. What was expected to be a dim speck became a radiant, emerald-colored spectacle, its coma swelling to nearly half the diameter of the sun. Imagine that, an alien traveler wrapping itself in a glowing shroud, bigger than anything we've ever seen at this distance. The eruption wasn't just unusual, it was impossible by every rule astronomers thought they understood. Even the most volatile comets rarely flare this dramatically, especially when still hundreds of millions of kilometers away from the sun. Yet here was Atlas, rewriting the playbook in real time. And just as the world turned its telescopes toward this shocking outburst, the comet made its escape, slipping into the solar glare at 70 kilometers per second, vanishing from Earth's direct sight. But the real mystery wasn't its disappearance, it was what came next. The numbers behind 3I/Atlas are almost impossible to wrap your head around. Right now, it's racing through the inner solar system at nearly 58 kilometers per second. That's more than double the speed of Mercury, the fastest planet we know. By the time it reaches perihelion at the end of October, it will accelerate to almost 68 kilometers per second, a velocity natural objects in our neighborhood simply don't achieve. To put it in human terms, Atlas could cross the entire distance between Earth and the Moon in just over an hour. Apollo astronauts, using the best rockets of their era, needed 3 days to cover the same gap. And while humanity's fastest creation, the Parker Solar Probe, will one day reach 200 kilometers per second, it will take years of slingshot maneuvers and careful planning to get there. Atlas achieved its blistering pace by doing nothing more than falling freely into the sun's gravity. But this speed isn't just a number on a chart. It's the clock ticking down, because Atlas is on a hyperbolic trajectory. It's not bound to the sun. This is a one-time visit. Once it slingshots past, it will vanish into the darkness of interstellar space, never to return. For Earth, the closest approach has already passed. No collision risk, no meteor showers, only the fleeting chance to witness a traveler from another star system. And with each passing day, that chance grows smaller. But as Atlas accelerated beyond imagination, astronomers realized they needed to act fast. And what followed was nothing short of a global scramble. The moment Atlas erupted, the world's most powerful observatories went into overdrive. Within hours, astronomers everywhere were scrambling to secure emergency time on telescopes that are usually booked months, even years in advance. The Hubble Space Telescope, already overscheduled, carved out a rare imaging slot, its ultraviolet and optical cameras capturing the comet's coma as it ballooned to cosmic proportions. The James Webb Space Telescope followed, locking onto Atlas with its ultra-sensitive infrared eyes. And what it saw shocked everyone, a CO2 to water ratio nearly 8 times higher than normal. An alien chemistry no solar system comet had ever shown. On the ground, the Gemini Observatory in Chile raced to snap rapid-fire images, while NASA's SphereX surveyor pivoted its all-sky scans to catch fleeting glimpses of Atlas's strange emissions. The data poured in at breakneck speed, but so did the confusion. Private Slack channels lit up with frantic debates over exposure times, filters, and calibration methods. Observatory schedulers juggled competing requests like a crisis team. while pipelines worked through the night to process terabytes of raw data. It felt less like routine science and more like a planetary defense drill. Except this time, the threat wasn't impact. It was the risk of missing a once-in-a-lifetime chance. But just as Earth's telescopes began to lose the race against the sun's glare, astronomers realized there was still hope. Another planet was about to take over the chase. As Atlas slipped into the sun's glare, Earth was blinded. But the story didn't end there. In a twist no one had planned for, Mars suddenly became humanity's last outpost for watching this interstellar visitor. Orbiting the red planet are some of the most advanced spacecraft ever built, and within days, they were reprogrammed to do something they were never designed for: track a comet racing through deep space at nearly 70 kilometers per second. NASA's Mars Reconnaissance Orbiter and its high-rise camera, capable of spotting objects the size of a desk from orbit, attempted the near impossible to capture the hidden nucleus itself. Meanwhile, Europe's Mars Express prepared wide-angle stereo images, perfect for mapping the comet's massive coma in 3 dimensions. The trace gas orbiter shifted its instruments to search for exotic molecules, chasing the strange CO2-rich chemistry first flagged by Webb. And NASA's MAVEN mission, built to study Mars's atmosphere, pivoted to monitor how Atlas's gases interacted with the solar wind, probing the physics of its eerie green glow. Behind the scenes, engineers and scientists scrambled in emergency meetings. Observation slots were bargained over like currency. Software patches were uploaded at the last minute, and safety teams weighed every risk. These orbiters weren't built to chase comets. One wrong setting could damage an instrument forever. Yet for a few tense weeks, they became the only eyes humanity had left on a traveler from beyond the stars. And just as Mars's robotic fleet began its watch, Atlas revealed something even stranger, a transformation no one could explain. At first, Atlas's coma was a muted haze, a faint red glow like countless comets before it. But then, something changed. Almost overnight, the shroud surrounding this interstellar visitor transformed into a vivid, otherworldly green, a glow so large it stretched over 600,000 kilometers across, nearly half the size of the Sun itself. For centuries, astronomers thought they understood green comets. The color usually comes from diatomic carbon, simple carbon molecules fluorescing when struck by sunlight. But when spectrographs locked onto Atlas, the expected carbon signature was nowhere to be found. The usual fingerprints of a comet were missing. Instead, James Webb's instruments revealed something astonishing: a carbon dioxide to water ratio nearly 8 times higher than anything seen before. And where scientists expected the classic carbon swan bands, they found only one culprit: atomic oxygen glowing at a forbidden wavelength, triggered as CO2 molecules were torn apart by sunlight and high-energy particles. In other words, Atlas wasn't just behaving like a comet pushed to the extreme. It was playing by rules written in another star system. A chemical fingerprint shaped in a nursery light years away, now glowing emerald in our skies. The eerie green glow became its calling card, the signature of a visitor from beyond. But Atlas wasn't finished breaking the rules. As astronomers debated the chemistry, the comet revealed an even stranger feature: a tail that defied everything they thought they knew. Every comet has a tail, a glowing streak of dust and gas driven away from the sun. But Atlas broke that rule too. Instead of trailing behind, a second tail appeared, pointing straight toward the sun. At first, astronomers thought it had to be an illusion, a trick of perspective as Earth crossed the comet's orbital plane. But the geometry didn't match, and the strange anti-tail refused to fade. Week after week, it held its place, defying the simple textbook picture of how comets are supposed to behave. The deeper scientists looked, the stranger it became. Powerful jets on Atlas's sunward side were blasting out huge grains of dust, larger, heavier, and more resilient than the ones carried by most comets. Instead of being blown away by sunlight, these grains resisted the solar wind and held their path, forming a real, physical tail that pointed in the wrong direction. Models showed the grains were at least 10 microns across, large enough to survive heat and radiation far longer than anyone expected. Their slow decay matched the fading brightness of the anti-tail, proving it wasn't a trick of light, but a structure built from dust and physics pushed to the edge. And yet, the mystery didn't end there. Plasma effects twisted and sharpened the feature, hinting at unseen forces sculpting its shape. To some, it was simply an extreme case of comet mechanics. To others, it raised darker questions. Could something more exotic be at play? For now, the anti-tail stands as Atlas's strangest signature, a sunward streak that shouldn't exist, but does. And as the comet raced toward its closest approach, scientists knew the real test was still to come. 3I Atlas was never just another comet. From the moment it erupted, glowing green and building a sun-sized cloud of gas, it challenged everything we thought we knew. It sped through the inner solar system faster than any planet, revealed alien chemistry unlike anything in our backyard, and carved an impossible anti-tail that pointed straight at the sun. And yet, for all the data and all the frantic observations, so much about Atlas remains a mystery. Was it simply a frozen fragment from a distant star, behaving in ways our models can't yet predict? Or was it something stranger, a messenger carrying secrets from another world, slipping past us before we could decode them? One thing is certain: Atlas is gone. Its hyperbolic path guarantees we'll never see it again. The window is closed, the opportunity fleeting. But in that brief moment, it left us with a challenge: to rethink the rules of comets, interstellar chemistry, and the boundaries of our knowledge. Because if Atlas could appear without warning, erupt in ways no one expected, and vanish just as quickly, what else is passing through the dark between the stars? What other secrets are racing past us, unseen, waiting for the day we finally notice?